Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to part 2 for my GameMaker Studio 2 random level generation series. We're going to finish up this series with this video. I'm not going to cover anything else after this. It should give you the basics. You can look at I'm going to link in the description to my older series. It actually covers a few other things. It was done in GameMaker Studio 1.4, but much of the code could be converted over to GameMaker Studio 2. So if you're looking for more, that might be where you can find it. Let's get started. The first thing we need to do, which I forgot to do in the last video, and it's very, very shameful of me, is we forgot to destroy our grid data structure. So if we run the game in debug mode and you'll see we have how much memory we're using up here, right? We've got 7,143 kilobytes. If I press R, you'll see this memory continues to go up every time I restart the room. That's not good. And the reason is because we're creating multiple, I'm gonna hit stop here. We're creating multiple grid data structures and we're not destroying the old ones. So we're gonna add an event to our level and we're gonna make it a cleanup event. And we're just gonna say ds grid destroy grid underscore. There we go. Now when we run our game in debug mode, and we restart the room, our memory doesn't increase each time we restart the room. So that's good. We're looking good. Okay. Now we're going to create a player that can move around in this room. So let's create a new object. We'll name this O_player. And did we import the player sprite? We didn't, so let's create a new sprite. We'll name this S_player. We'll import right here the sprite. Yes. We'll import the other sprites too, just because. Import the player shadow. Yes. S_player shadow. We'll set the origin on this to middle center, and then we'll import another one, which is just the normal shadow. Yes, S shadow. I think we leave the origin on that one where it is. And for the player, let's set the origin on the player as well. We're going to set it to a custom, and I'm just going to set it to 9. And 22. That should be about at the player's feet. That's where we'll create the shadow pretty much. Once we've done that, we can assign the player sprite to the player object and create some variables. X speed equals 0. Y speed equals 0, max speed equals 2, and acceleration equals 0.5. I'll do 0.5, makes it a little bit more readable. Cool, we're good to go. Now we'll add a step event. Well, let's add a draw event real fast because we can do that. We're just going to draw the player in the shadow. So we'll say draw sprite ext s player shadow 0. Let's get a little bit more room here so we can see this better. 0 is the sub image. We'll do x, y plus 1. 1 for x scale. Negative 0.75 for our Y scale. Rotation will be 0. Color will be C white. Alpha will be 0.3. No, 0.5. 0.5. And then draw self. So this will just draw the shadow and then draw the player on top of it. Okay. Now let's run our step event. Now this is going to get a little bit advanced here. And this tutorial is for more advanced users. I'll try to explain it, but I'm going to leave a link in the description that talks about using bitwise, or a tutorial in the description that talks about using bitwise operators for collisions that I did. And you can use that basically to understand this code, because a lot of this code is very similar to that video. So we'll say var x input equals keyboard check vk right minus keyboard check vk left. I guess our x-axis on the input, y input equals keyboard check vk down minus keyboard check vk up. Then we need to alter our x speed and y speed. We're going to add our input, our x input times our acceleration. So we're taking our x input, multiplying it by our acceleration, and adding that onto our current x speed. Do the same with the y speed. Only y input, obviously. Now we want to add friction, so we'll say if x input equals 0, x speed equals lerp, x speed 0.3, and we'll do it for our y speed as well. If y input equals 0, y speed equals lerp, y speed 0.3. Now you could store these in acceleration variable. That'd probably be the best thing to do, but this series isn't really focusing on that. It's focusing on the random level generation and how you can get a character to collide with the walls. So this code can obviously be improved. And we'll say if x input equals 0 and y input equals 0. This is for our animation. We'll just say image speed equals 0, image index equals 0. Else image speed equals 0.7. Okay, so we've set our x speed and y speed, but we haven't actually moved yet, so that's what we're going to do now. I'm going to give myself a little bit of space here. Okay. So we're going to move, we'll say x plus equals x speed. That should move us. Now we need to detect our collisions. So if x speed is greater than 0, we're colliding to the right. Else, if x speed is less than 0, we're going to check for collisions to the left. And we'll do this by saying okay, so now we need to create a script. And this script is going to allow us to detect if a certain object is colliding with the grid, and we're just going to check each corner of the object. So let's create a new script. Create script. We'll name this grid place meeting, and we'll just do arg object. We're going to pass in two arguments. Grid, so we'll pass in a grid and argument, or an object and a grid, sorry. Object equals argument 0, var grid equals argument 1. So we'll use this grid to detect collisions, right? And then we'll just do var top right, so we're checking the top right corner, equals grid, okay, object dot bbox right minus 1 div cell width. So that's our X position that we're going to check. We're going to do object dot bbox top div cell height for our Y. We don't have to subtract 1 from that. And then we'll say equals void. So if this position in our grid, using our object's top right position and then dividing by the cell width and height, if that is a void, we know that there's a collision on the top right. Okay? And we're going to do this for all the corners. Var top left. If you have an object that is, if the sprite of your object, or the collision box of your object is actually larger than your grid size, then you're going to need to do more points. You won't be able to do just top right, top left, bottom right, bottom left. You're going to have to do more points on those edges to make sure that it'll work. Grid object dot bbox left div cell width, comma, object.bbox top div cell height equals void. Var bottom right, grid, okay, we'll do, oops, this object right here is wrong. There we go. Object, this one's going to have to be in parentheses because we're going to do a -1. Object bbox right, -1, div cell width, object dot bbox bottom. This one also has to be -1. So we need parentheses around it. Order of operations, div cell height equals void, var bottom left, grid, object.bbox left, div cell width, and then parentheses, object.bbox bottom -1 div cell height equals void. Okay, so we've checked every corner. Now we're going to return top right or top left or bottom right or bottom left. So if any of these return true, if any of them are true, then our whole function will return true and say, oh, we found a collision. That's why we're doing OR. That way, if this one's 1, then it'll return 1. Okay. Now we can go back into our player and actually use this. So we'll say if grid place meeting self object level dot grid. So we're going to grab the grid. We need to do our collision. We'll say x equals bbox right and sign little squiggly parentheses cell width -1. So that moves us to our correct spot. We need to do a little bit more movement. X minus equals bbox right minus x. And then we need to set our x speed. X speed equals 0. Okay, like I said, this right here, this is tricky math. But there is a link in the description that will go into more detail about how this works. Okay? So I'm not going to go into a thorough explanation right now because I've already done it before in a different video. So you can go watch that video and learn exactly how this math works. Okay, now we're going to do left. If grid place meeting self object level dot grid. Then to the left, it's going to be x equals bbox left and squiggly cell width -1 x plus equals cell width plus x minus bbox left x speed equals 0. So we've done it for the x. Now we just need to do it for the y. So y plus equals y speed if y speed is greater than 0. We're colliding down. Else, if y speed is less than 0, we're colliding up. So if grid place meeting, you could really just copy this bit here because it's going to be the same. Okay, then the collision, we'll do the collision. It's going to be a little different here. We'll say y equals bbox bottom and squiggly cell height -1 y minus equals bbox bottom minus y speed equals 0. Then for the top collisions, for colliding upwards, we'll say y equals bbox top and squiggly cell height -1 and y plus equals cell height plus y minus bbox top y speed equals 0. Okay, hopefully we got all this right. We need to make our camera though as well. So let's make a camera object. Create a new object and we'll call this object camera. And we'll give it a create event. In this create event, we'll give it a variable called target. We'll set it equal to object player. We'll give it a width. We'll do camera get view width and then view camera 0. We'll give it a height. Camera get view height view camera 0. Oops. There we go. And that should be good for now. At this, wait. Oh, I forgot my equals sign. Now we'll add a step event. In here we'll say if not instance exists, target exit. So there's exit if there's no target for the camera to follow. X equals lerp x target dot x 0.1, y equals lerp y target dot y 0.1. So we'll just move slowly towards the target. Then we're going to clamp our position. Say x equals clamp x width divided by 2 plus cell width room width minus width divided by 2. I need more room here. Let's get some more room. Minus cell width. Remember how we have that extra cell on the edge that's not being used just to make things easier? We are now using it because we're going to hide that information. Why do I have an error message here though? I'm not sure what I'm missing something here. Comma or something. I don't know. Y equals clamp y height divided by 2. I've got an extra comma, that's why. Right there. Plus cell height, comma, room height minus height divided by 2 minus cell height. Okay, was that my issue? Yep, it was. There we go. Camera set view position. View camera 0 x minus width divided by 2 y minus height divided by 2. There we go. So we clamp the camera's position and then we set the camera's position right here because we've just been changing this object's actual X and Y position. And now we're actually going to set the camera's X and Y position using this. So this is definitely different in GameMaker Studio 2 than it was in GameMaker Studio 1.4. And this is kind of like the lazy way of doing it, where you don't have to learn a whole bunch about cameras to get this to work. So now we need to make sure that our room is set up correctly. So let's come into our room down here. And please, for some reason when I had this room open earlier, GameMaker crashed on me, so I really hope that doesn't happen. Now we need to go into the room properties. Down here, we need to come into views and cameras. We need to enable viewports, come into viewport 0, set it to visible. And then we're going to set our width equal to 320, our height equal to 180, and this is the camera properties. And then the view properties, we're going to do 1280, and the height 720. That's the view properties. And we should be good to go. Oh no, our horizontal border will be 160. I don't think this matters. No, this doesn't matter though. That's fine. Vertical border will be 90. It doesn't matter because we're not using object falling. Okay, now our player, in the create event for the player, we need to actually create the camera. So inside of our player's create event, let's add a little line of code here. Instance, create, layer, do X and Y, do the instances layer, and object camera. Let's run the game and see how it works. Hopefully, we wrote a lot of code without running the game, so it's possible we could have issues here. Oh yeah, we're not actually creating the player. So there's an issue. Come back into your level object, and in the create event, we're going to We're going to set up our player start position. We'll do that right. We'll do it after the steps right here. So we'll say var player start x equals controller x times cell width plus cell width divided by 2. Var player start y equals controller y times cell height plus cell height divided by 2. Instance create layer player start. Gotta wait for my variables to kick in. There we go. Player start x, player start y, instances, and then object player. Okay. Oh, I got a parenthesis there somehow. Okay. No more errors. Save, run the game. And there we go. Except for, I think our collision, there's obviously still enough stuff we need to do with our player. So come back into the player and to the step event. And we need to have a bit here for checking the players, basically the direction they're facing. So we're going to do that right here before we move the x. We'll say if x speed is greater than 0, else if x speed, this sounds very familiar, doesn't it? Just put it right in here. We'll just say image x scale equals 1, image x scale equals -1. Okay, this is different from the source I have up on GitHub, but that source might be updated a little bit anyways later. So I can't guarantee this will be exactly the same, but it will give you the general idea. So after we add the x speed and y speed, we actually need to cap our max speed as well. So we can't move too fast. So var speed equals point distance 0, 0, x speed, y speed, y speed. So that's our total speed, right? If you add the x speed and the y speed, you get the distance between the two. It's basically the vector for our speed. We need direction for it too. Direction equals point direction. And this is going to be exactly the same stuff. There we go. Then we'll say if speed is greater than max speed, x speed equals length dir x max speed direction. So we're just clamping our total speed. Y speed equals length dir y max speed direction. Okay. We also need to set the player's collision mask. So this is important. We're going to do a manual collision mask, and we're going to set left to 4, not 41, 4, right to 13, top to 15, and bottom to 23, and that should be good. Okay. Let's try this again. Now, if we're still having issues, it could be because we're not calculating something correctly. But this seems to be working, the collisions do. So our code looks good. It's moving really slow. I may have actually, these values may be based on if you come into your options main, set your game frames per second to 60. I think maybe the values that I chose were based on 60. And this seems to make a little more sense. Well, I don't know, except for the friction feels really strong now. Stop like instantly. But maybe that's what you want for your character. It all kind of depends. I would set the friction quite a bit lower personally. So like instead of having a friction of 0.3 right here, I'd do something. Let's try 0.2 and see how that goes. This feels better to me. So I've noticed this moving to the right works perfectly fine up against walls, but I've noticed that moving to the left and moving down, not if you stop, but if you keep holding down, the character kind of jitters a little bit. Same with up. And my guess is that my math somewhere is off by a single pixel, but I'm not exactly sure where that is. So I'm going to have to go through that and figure that out. I'm not going to cover it in these videos because I don't see the point in covering it in these videos later, like making a whole video for when I figure it out. But I will update the source code on GitHub. So when I do get that figured out, it seems to be a little bit of a bug. And like I said, I think my math somewhere is off by just a single pixel. If any of you guys figure out why that is, let me know. If you figure out where my math is off or why I'm getting that slight jitter when you hold over against a wall. You could use a check before you move, probably to get rid of it. So instead of just moving the X right here, you could add to our X position first and see, oh, is there going to be a collision if we move this much? And then if there is, don't worry about, well, no, because, yeah, that wouldn't work either. You just have to fix the math. We've got to fix the math. So anyways, when I do get that figured out, I'll update it in the source code. So you guys can check that to see what changes I made to the source code. And I'll comment it as well in the source code so you know exactly where to find that when I do figure it out. It seems like a really minor thing to me because it's only barely visible and only if you just keep holding against the wall. But, you know, it does seem like I've got something off there. Anyways, the last thing that we're going to do in this video, it's getting to be a longer video because this is a slightly more complicated issue, but the last thing that we're going to do is we're going to set up a surface. So in our create event up here, we'll create a surface, shadow surface. This surface, we'll just set it equal to no one for now. We're going to use this surface to draw the shadows for the walls. Make sure that once we've created it, I'm not going to forget this time. We're going to go right into the cleanup and we're going to say surface free shadow surface. We do not want a memory leak, so we're going to make sure that that's done immediately. Now we're going to come into the draw event. And in this event, we have to have a check here. We need to make sure the surface, if the surface doesn't exist, we need to create it. So we'll say if not surface exists, shadow surface. And the reason we have to do this is because surfaces they're volatile, so they can be removed if you set the game to full screen or something. And so we need to recreate the surface every time something like that happens. So we'll say shadow surface equals surface create room width, room height, surface set target, shadow surface. So we'll set our target for drawing. Draw clear alpha. We'll set it to C black and an alpha value of 0. This just clears our surface all the way. Then we need a for loop. Var y equals 0. Y is less than height minus 1. Y plus plus. For var x equals 0. X is less than width minus 1, x plus plus. Then we'll just say if, we're going to check our grid. So we're going to say if grid x, y is equal to floor and grid x, y minus 1 is equal to void. So if our current grid cell is a floor, but the one above us is a void, then we know we want to create a shadow. We'll say draw sprite ext s shadow 0. Then our x position is going to be x times cell width, because we need to convert from grid cells to in-game pixels. Y times cell height. And then 1, 1, 0, C white, 0.5. So our alpha will be 0.5, scale will be 1, 1, rotation 0. Then after we've drawn that, we'll just set surface, reset target, and that creates the surface, and then we just draw it. Draw surface. This is outside the loop, obviously. Shadow surface, 0, 0. So the benefit of this is we only actually loop, this for loop only happens once when we create the surface, and then from then on out we no longer need to do this for loop, and that's why we're using a surface, is so that we can only execute this for loop once, save that information to a surface, and then draw it. And you can see now we have shadows inside of our grid using a surface inside of our level. Everything's looking really good. So thank you guys so much for watching this series. Hopefully you enjoyed it. Remember, GitHub, I have the source up there. If I make slight tweaks and changes to this source code, you can go see it there. You'll be able to even see the changes that I make just by clicking on the commit history. So you can see exactly what changes I make to the code as I do that. Thank you guys for watching this series. Hope you'd enjoyed it. If you did, give it a thumbs up, and I will talk to you guys later.